We're going to be looking at how to use the GIF Continuum K3 with Stela to acquire EELS spectrum imaging data using the Stela camera. The Stela camera uses the Dectris ELA sensor, which is a 1024 channel hybrid pixel electron counting sensor, which is highly optimized for low kV experiments. So I'm running the microscope in STEM mode at 80 kV for this demonstration. As you can see from the microscope user interface in Digital Micrograph, we have a fully loaded system, but I'm just going to be focusing on the Stela for now. The sample I'm looking at is a fib lamella of single crystal barium titanate, and I'm starting off with a 0.3 eV per channel energy dispersion. We can expect around 0.3 eV energy resolution at 80 kV, so I should achieve a single channel full width half maximum in the zero loss peak, whilst also maximizing the energy range per spectrum. So the energy range per spectrum is 307 eV. To collect the low loss spectral data with the titanium and oxygen edges I'm interested in, I need to use dual EELS mode to extend the energy range. I've also enabled ZLP lock for live energy drift correction, as I'm going to be collecting spectrum images in multiple pass mode. In HQ mode, the maximum frame rate for the Stela camera is 4400 FPS. I've set the low loss and high loss exposure times at this frame rate to maximize signal collection efficiency for my experiment. As you can see from the SI acquisition palette, I'm going to acquire a 90 by 95 2D array spectrum image with 100 passes. I've also enabled live mapping so I can monitor the signal to noise ratio live, so I can stop the capture early if I want. Now all I need to do is hit capture. As you can see, the steps to acquire spectrum image data in Digital Micrograph using the Stela camera are much the same as any of our other supported EELS cameras, and all of the processing and analysis tools that we are familiar with behave as you'd expect. I'll go ahead and use the Spectrum Picker tool to extract spectral data from the high loss spectrum image. I need to resize the window and rearrange a little, and now I'll just drag and drop the same picker region onto the low loss spectrum image to mirror the ROI and extract low loss data from the exact same specimen region as the core loss data we just pulled out. I can use the splitter tool so we can see the zero loss peak and low loss features nicely in that low loss spectrum. As expected, I have a single channel full width half max in the ZLP, so my energy resolution is 0.3 eV. We can see really good signal to noise ratio in the low loss, and the titanium L23 edge after around 10 spectrum image passes. I'm easily resolving the multiplet peaks on the titanium white lines with this energy resolution. Now I'll just add a pre-edge background window and hit deconvolve in the EELS analysis palette to perform a live Fourier ratio deconvolution on the core loss spectrum as I let the multiple pass acquisition continue. I'm pretty happy with the signal to noise ratio and how it's improving in the oxygen K edge. It looks like I'll be about where I want to be with 100 passes, so I'll let the capture run to completion and not finish early or add any more passes. So that's all I want to show for now. Thanks everyone for listening, and see you next time.